So we're going to be continuing notes 3.4, part 2. Alright, a conjugate pair. I've mentioned it previous. Conjugate pairs are A plus BI and A minus BI. Notice that A has the same sign. A may be positive, A may be negative, but we don't change the sign of the first term. The only thing that changes to create a conjugate pair is the operation. So if I had addition, I'd change it to subtraction. If I started with subtraction, I'd change it to addition. Nothing else changes. Okay, so right here, the conjugate pair, its partner, think of this as being 0 plus 3i. So I wouldn't change 0, but I'd change plus, adding to subtracting, which makes it negative 3i. Think of this as 0 minus 7i. So the conjugate pair would be 0 plus 7i. 2 minus i's partner is 2 stays the same. Change subtraction to addition. Negative 3 plus 5i's pair partner is negative 3 minus 5i. So the only thing that changes to create a conjugate pair is the operation. We're going to see in this video why we care about knowing about conjugate pairs. If a plus bi is a 0 of the function, then a minus bi is also a 0 of the function. Imaginary zeros occur in conjugate pairs. Alright, so what are we going to be doing with that information besides just knowing that imaginary zeros occur in pairs, conjugate pairs? Here's one of the objectives. We're asked to find a polynomial function with real coefficients that has the given zeros. So they're giving us the solutions and asking us to find the function that these are solutions of, or zeros of. First, identify that you have an imaginary solution. So, as mentioned previous, imaginary solutions occur in conjugate pairs, so not only is 3i a 0, as well as negative 3i. So at this point, if I have 4 zeros, I need to create a 4th degree function. Well, if these are the solutions, let's create the linear factors that these solutions come from and do a lot of intense multiplying. So f of x is equal to x plus 1, x plus 1, double root, x minus 3i, and x plus 3i. Alright, if this wasn't the direction up here to find real coefficients, we could almost just leave our answer in factored form. But because of this statement right here, real coefficients, we have to get rid of the i's. Next line down, f of x equals. Well, let's be organized in our work. It might be smart to multiply these two binomials together. FOIL, box it, your preference. And then let's go ahead and multiply these two binomials together. When I multiply these two binomials together, I'm going to get a trinomial. The x's give x squared when multiplied. The outside, no, that's the first terms. Here's the outside. That's plus x, but then you have to go to the inside, and then the last terms. So I'm going to get a plus x and another plus x, which will collect to 2x, and the 1's multiply in the last positions to 1. But here's where we're interested in multiplying. These are conjugates, negative 3i and 3i, and think about when you multiply these binomials together. Okay, that product of course is x squared, but when you do the outside multiplication, you're going to get positive 3ix. But when you go back and multiply the inside terms together, you're going to get minus 3ix. Well, plus 3ix and minus 3ix are going to cancel to 0. So all we have to do yet is just multiply the two last terms. So in FOIL, when you have conjugate pairs, the O and the I, the outside and the inside, are going to cancel. So really all we have to do when we identify this kind of situation is multiply the two first terms and the two last terms. So the product of the two last terms would be minus 9i squared. So nicely right here, I squared is going to change to -1, but we go in and we make the adjustment, and so we say that this was going to be, or this is going to be x squared plus 9. And that makes sense. If I have 3i and -3i, it had to come from this factor, that quadratic factor. Alright, not done. Let's be organized in our work. Multiply all three of these terms by x squared, then come back and multiply all three of these terms by 9. If you prefer to box, that's fine. So the first product, x squared and x squared, gives x to the fourth. We add exponents. 2x times x squared gives 2x cubed. And the last product gives x squared. Next, we're going to multiply these same three terms of the trinomial by the 9. That's what you're doing in box. It just organizes it for you. So x squared times 9, 9x squared. 2x times 9 is 18x. And the last product would be 9. We have a little cleanup and then we'll be finished. Collecting like terms, just kind of lightly cross off once you record down here. Nothing collects with 2x cubed. 2x squared terms collect to 10x squared. The remaining two terms have nothing to collect with, so bring them down. I had 4 zeros, so I should have a fourth degree function, and all the coefficients are real numbers. Example 2. Same objective. If I have a 0 of 7i, then I have to have a 0 of -7i. So first look for any missing conjugate pairs of the imaginary zeros, include them, and then build your linear factors. 2 comes from the factor of x minus 2. -2, that 0 will come from the factor of x plus 2. And then the two remaining imaginary factors. What's nice is you can see that these first two binomials create a sum and difference of like terms. Same thing here. So multiplying these two binomials, I'm going to get x squared minus 4, because in FOIL the outside and inside terms will cancel. Likewise here. You can FOIL and do that work, but because we have sum and difference of like terms, all we have to do is multiply the first terms and the last terms. A little more cleanup to do. Remember, I squared is -1. So multiplying by -49 is going to give x squared plus 49. And then I'm just going to FOIL. So x squared times x squared gives x to the fourth. Outside, 49x squared. Inside, minus 4x squared. Oh, brother. Minus 4 times 50 is 200, minus 4, 196. Slight cleanup. We've created a fourth degree function. We should have, because we have 4 zeros. All right, our next objective. Looking at the next objective, use the given 0 to find all the zeros of the function. Okay, each of these problems is probably going to take us a little bit of time because there's multiple steps. So I think I'll just create another video. Otherwise, this one might be too long. If I tried to do these two here, then there might be issues with the sound quality. So I'll see you in just a second.